1-5 in Advanced Algebra 1, solving more equations. This time we've got x's all over the place and numbers all over the place. They could use other letters, but here's the basic idea. We need to try to get all the variables on one side of the equation and all the numbers on the other side so we can solve for it. So can you kind of see, here's 2x, there's 3x. Question, are they on the same side or different sides of the equal signs? Different sides. You see the 5 and the -2. Here's what we want to do. We want to move all, there's many ways to do this, by the way. Here's the way I like to do it. I want to move all the x's to one side. And I kind of go like this. It's just like, hey, I'm going to move the smaller amount. Who's smaller, 2x or 3x? Who's the smaller guy? So I am going to move that 2x over to the other side by subtracting. And again, if I do it in purple, that's what I call a baby step. You don't have to literally show that. But the more complicated this gets, the more people run back to the baby steps. And they're like, I kind of need that. You know, I'm new at this. You know, so there's no shame in doing it. But those, cancel out. Isn't 2x, take away 2x, gone in that case. So then 5 comes down. Equal sign comes down. What's 3x take away 2x, baby? 1x, which I'd rather us not put the 1 in front of it. I mean, it's not wrong, you know, but I think we know that, right? There's a 1 in front of that situation. And then there is also a -2 there. Are you with me on how I have moved the x's to one side of the equal sign? Now, I've got to move the numbers to the other side. I get no choice now, right? I got to choose which x's to move to what side. Now I got no choice. Don't I have to get rid of this -2, right? So I get rid of -2 by adding 2 to both sides. And 7 equals x. Are you cool with that? I'm getting all the x's on one side, getting all the numbers on the other side, right? So let's roll with that again. Who's the smaller amount of x's, the 5x or the 4x? So I feel it's a better move to move the smaller amount of x's by doing the opposite. I'll explain why here in a little bit. 5x take away 4x is 1x. -7 comes down. Oops, I shouldn't have done that in purple, but too late. I'm not going to erase it. Then I can get rid of that -7 by adding 7 to both sides. Moving all the x's to one side and all the numbers to the other. I don't care which side the x's are on or which side the numbers are on. It's just that's the concept. Feel all right with that? Why don't you pause the video and try number 3 for yourself? So we're going to add 8m to both sides. It's not the only move you could do. It's just the move I like. 2m plus 8m is 10m. -13, comes down. Equals comes down, and then you get a 27, right? Then, of course, shouldn't we add 13 to both sides, right? You know, so I will do that. Don't be afraid to use a calculator. There's nothing wrong with that. 27 plus 13. Is it 30 or is it 40? Yeah, 40. And then divide by 10, divide by 10. That comes out nice, right? What's 40 divided by 10, baby? 4. You feel pretty good with those, moving all the letters to one side, all the numbers to the other. So we'll rock that again. I'm going to do this one different, just to show you, like, you can do it differently. Who's the smaller guy, the 3t or the 8t? 3t. I'm going to move the 8t. Just because I can. I can do that if I want to. See if you like it. If I move the 8t, I'll have -8t minus 8t. You might start noticing that I make my t's with a little tail on them so they don't look like plus signs. Start learning that, the easier math will become so you can read your own handwriting. All right, so I'm going to subtract the 8t, and look how ugly this gets. 4 comes down. What's 3t take away 8t? I get a negative amount of t's, right? That's why I don't like doing it this way, because I know I'm going to get negative amounts. But who cares? I can still deal with it. So -5t equals -14, right? Then if I subtract 4 from both sides, boom, -5t comes down, and that's -18. And what's my move, man, to get that t all by itself? Should I add 5 to both sides or divide by a -5? Yeah, divide by a -5. And, of course, that does clean up. because it's a negative over a negative. Everybody knows the answer, what it should be. What's a negative divided by a negative sign-wise? It is a positive. My question is, does 18 over 5 reduce at all? Does like a number go into each one of those? So the answer is 18/5. Let me ask you a question. Did you like dealing with all those negatives? That's why I moved the smaller amount of the letters first, you know. It probably eliminates that issue, you know what I'm saying? So there's other ways to do it. Some ways are smoother than others. So on number 5, who would you like to move first? The 4x or the 6x? The smaller amount. Move that over. Work together on it. Pause the video, see what you get. So I subtracted 4x from both sides and got this. And now my move is to subtract 9 from both sides. So I got 2x equals 3. Ew, I don't like it, but there's nothing wrong with it. I still got to get x by itself, get rid of that times 2 by dividing by 2. And I don't want you to put 1.5. I think we talked about that last time. We'll just put 3/2. Is that okay with you? I just filled out our review packet. You know, it's not really even a packet, but almost all of them come out weird like this. You know, it's like I'm trying to train you that not everything comes out nice, you know, so it's totally okay if that happens. All right, all of those were kind of basics. Something's really different about number 6. Look at these. Boom, boom, and boom. Isn't there a bunch of T's all over the place? Why did I highlight 2 of them orange and the other one blue? Discuss with a neighbor. What do you do? What's true about them orange boys? They're on the left side, aka they're on the same side. You combine those together. Add them up. They're just all hanging out on the left side of the teeter-totter in that case. If there are negative 2 T's and a positive 3 T's on the same side, you just add them up. That's just 1 T. Are you down with negative 2 plus 3 is 1 in that case? So we combine like terms if they're on the same side of the equal sign. The only time you do the opposite thing is when you're trying to move from one side of the equal sign to the other, right? So because the orange boys were on the same side, we combine them, right? We add them up. They are like terms. Is that okay? Is that ringing a bell? Okay. If you need help with that on homework, you let me know. And now, look at these T's. Aren't they on different sides? You know, like one of them's on the left side, the other one's on the right side. That's when we do the opposite thingy-mo-bobber, right? So I'm going to move the single T. I'm going to subtract this T over. Use a pen. I'm going to subtract that T over. So minus T, minus T. 1 comes down. 5T take away 1T is 4T. And then minus 9 comes down. And then I shall add 9. Add 9. And get me a 10 equals 4T. And then divide by 4. Divide by 4. Ooh. What if I type 10/4 into my homework program? It's going to say wrong. Even though it's not wrong, but it is wrong. What's wrong with a 10/4 for an answer? Can't it reduce by 2? Doesn't 2 go into each one of these guys, right? So how many times does 2 go into 10? And 2 goes into 4. So 5 halves on that. Reducing a fraction. If you need help reducing fractions, I will help you with those also. Rock on? So that's the basics. Now let's get to the scary town. I would wager to say that we could do all of this without a calculator. You know, people see all these fractions and they're scared to death, but they just don't know how to deal with the fractions. So what I'll show you is how to make them disappear. Right? I'm going to just get rid of the fractions. I don't like fractions any more than anybody else. So in this gray box it says if you just multiply every term times the least common denominator, things are going to work. I'd rather call it the least common multiple. And because this is the first time explaining it, at least me to you, I'm going to do it like this. What if first of all, let's look at the 2 denominators. Isn't one of them a 2 and one of them a 5? Are you with me on that? If I wrote out a list of multiples of each one, like multiples of 2, 2, 4, 6, 8, 10, 12. You down with me that those are multiples of 2, right? And I wrote out multiples of 5, 5, 10, 15, 20, 25, 30, etc., right? Who's the smallest number that's in both lists? Isn't 10 the smallest number? That's why it's called the least common multiple. These are multiples of 2 and multiples of 5. That is the smallest one that is common to both lists, the least common multiple. So what we'll do, and this is the work that I want you to show, is we'll throw this whole mamma jamma in parentheses, and we're going to take everybody times that least common multiple, which is 10. And the reason why I need the parentheses is because I'm going to distribute the 10 through. But here's my question, dog. How many terms are inside of these parentheses? Terms are separated by addition signs, subtraction signs, or equal signs. Talk with a neighbor. How many terms are inside of those parentheses? There are 3. You see that orange dude right there, that green dude right there, and that blue dude right there? Isn't there 3 different terms? So we'll take everybody times 10, but it's going to come out so nice because we made this 10 be a multiple of these denominators. So how many times does 2 go into 10, baby? 5 times. Then you take that times the numerator and you'll still get a 5, but there is a z with it. Please start learning to cross your z's so they don't look like 2's. Like put a little cross in there. I'm not going to mark you wrong if you don't cross your t's, but it's just one of those, you got to trust me. There's a lot of this. Like, does that say 22 or does that say 2z? You know, it's like, I don't know. Now it's for sure. That says 2z, right? So you don't get lost in your own work. So I multiply by 10. Here's the big move that gets forgotten. What do you think? Does that 10 need to be taken times the 9 also? You got to keep everything balanced, right? You got to multiply everything times that. So that's going to be a 90. I forgot my equal sign. A 90 right there. And then here's what I do. I don't give a crap about the signs after the fact. I do that beforehand. This is a positive 10 times a negative 3/5 z. It's a positive times a negative. What's that sign going to turn out to be? A negative. I figure out the signs first, right? You know, now I don't worry about the signs. I just roll with the numbers. 5 goes into 10 twice, right? Times the numerator. Wouldn't I get a 6? And there is a z with it. Are you cool with me multiplying everything through just like we did last week, you know, kind of clear those fractions? Which equation do you like better, the OG or the new guy? New guy's beautiful because there is no fractions in that guy whatsoever. Please pause the video and solve that for z. I'm going to add 6z over to both sides. You guys cool with doing the opposite move, right? So you get that over there, adding that over. So boom. That's 11 z's equals 90, and those cancel out. I think we know our next move is to divide both sides by 11, right? That going to come out nice? I don't know. I forgot to open my calculator. If I type in 90 divided by 11, I get a weirdo decimal. I don't want that, so I'm going to do 90 11ths on this guy. Let's try that again. That was kind of weird. Look at your denominators. Can you find the least common multiple? If you think about all the multiples of 3 and all the multiples of 5, who's like the smallest number that's in both lists? 15? Cool. So let's take that times everybody times 15. And the idea is you're seeing how many times does this denominator go into 15, then times the numerator. So 5 goes into 15 3 times, times 2, which is a 6x. 15 times 4, got to do it. And 3 goes into 15 5 times. Taking that times the numerator, I got a 10x. That's what I get when I clear the fractions. Here's the secret. If you struggle finding the least common denominator, just multiply these two guys together, and that will at least be a common denominator. It might not be the least common denominator, but it'll still work for you, right? So if you're struggling finding a common denominator, just multiply them all together. That number will always work. But sometimes he's, oops, my bad, sometimes he's a big boy. So I'm going to subtract the 6x over. 60 come down. 4x. Divide by 4. What do we get for x, baby? 15. It's not negative. There's just a dash there. So. How do you feel about clearing fractions, only just with 2 situations going on? Let's try another one. Ew, fractions. I hate them. I'm going to clear the fractions. There's 4 of them. Big deal. I look at the denominators, right? There's actually only two different denominators. Are you with me? 2's and 4's. If I wrote out a list of multiples, here's my question. Is 2 the least common multiple, or is 4 the least common multiple? Discuss. A lot of people get it backwards. If I wrote out a list of multiples of 2 and multiples of 4, isn't 4 the smallest number in both lists, right? So we got to take everybody times 4. Sound good? So let's throw parentheses. You got to show that for me. I want to see that. Put parentheses around the whole mamma jamma. And why don't you take everybody times 4 and check it with mine. Here's the most interesting one. People have a great question about that. Shouldn't this disappear, Mr. Fonenstiel? And I say, that is an awesome question, right? They're like, well, the times 4 and the divide by 4 cancel each other out. They cancel each other out is a phrase that gets misused. Cancel each other out means multiply together to be 1 is what it really means. Like they multiply together to be 1, so like you still have to take it times the numerator, so that doesn't actually disappear. Are we okay with that? That's a good question that people ask. So, all right, I'm going to subtract 3x. You can do the next one if you're waiting on me. And then I'm going to subtract a 1, and that's a negative 3. Oh, hold on before you get too far on the next one. Could you tell me what my move is to do this? Should I add 3 to both sides, subtract 3 from both sides, divide by 7, multiply by 7, subtract 7, add 7? What's my move here? Divide by 7. I think we got that. Here's the question, though. What's the answer turn out to be? Is it this in red? Is it this in green? Or is it this in blue? What is the answer? Or does it even matter which one of those 3? Is the answer supposed to be negative 3/7? Yes or no? The red one is negative 3/7. Are you with me on that? Is the green one still say negative 3/7? You know, even though the negative is down in the denominator, right? So it's cool. And see how I put like the negative in front of the fraction bar on the blue one? It's all the same thing. It doesn't matter where the negative sign is, but I'm going to put a purple one on here. Is this the same thing? Is that purple one the same as the other ones? A negative over a negative, right? Is that, say, negative 3/7? That's a positive 3/7, bro. You know what I mean? So that does not work. All right, back to where we were at. What do you want to multiply by to clear the fractions? On 10. Who's the only denominator you got? 8. I'm going to get rid of them by taking it times 8. You know, that's the least common. It's the only denominator, right? So if you take everybody times 8, we're rocking, baby. We're rocking. 8 goes into 8 once. Take it times the numerator. Find my mistake. I made a mistake. Find my mistake. Tell your neighbor what you think. What's my mistake? That is wrong. It's also in red if you were looking that hard for my mistake. Find my mistake. Why shouldn't that be plus 2? I didn't take it times the 8. What should it be? Plus 16, baby. Plus 16. Hey, there's not x's on both sides. Cool. That's a bonus, right? We don't have to move the x's. Don't we need to move the 16, though? So minus 16, minus 16. Negative 3x comes down, and 7 minus 16, is that negative 9? Is that right? Cool. My bad. Divide by negative 3, divide by negative 3. What should x equal, baby? What's negative 9 divided by negative 3? Positive 3, baby. So we're clear in fractions.